So people have to look into carefully, like if they find something is abnormal in like any kind of a symptom, or something is recurrent, or yeah, even a slight like a change in the body temperature will actually tell, okay, the body is trying to fight against something, and that should not be ignored. And I think, yeah, there are a few other questions maybe.
Hi, Shubham.
Yeah. Hi.
Good morning.
Yes. Good morning, Kaushik.
So, yeah, hi, Kaushik. I
Doctor,
think, yeah,
Doctor
Dr.
Ashwini
Abhimanyu.
had introduced you, so maybe we can introduce.
Sure. So shall I begin my presentation? Shall I
Yes,
Yes.
present my slides? Sure.
yes. We welcome you, Dr. Venkat. Present your slides.
Yeah. Thank you. Kindly confirm if you could see my slides.
Yes, yeah, the
That's
screen is
Yeah.
visible.
Could you kindly confirm? Can you see my? Yeah. Awesome. Great. Yeah. Thank you very much for joining in. So today, as Shubham and Aparna mentioned, today we would be discussing a bit more on the advanced cell culture systems, which is 3D cell culture systems. And at the same time, we'll touch upon few points that how 3D cell culture systems would be helpful in cancer research. Moving on, all of you, I would like to start my presentation with a small analogy here. I hope all of you are very much aware about Mario game. I guess most of you might have played this game. So in 1990s, when we used to play this Mario game, the picture is so blurred. We used to play in a 2D format where the Mario used to go from left side of the screen to the right side of the screen, eating some mushrooms and doing some activities, and then growing big, becoming small, right? So there were not many, 2D games which we played, and Mario is one of it. So when we see the recent evolution of these games, it were more right now we are more into 3D world where you see the characteristics, the characters moves in all the directions. Especially if you see this 3D Mario in the recent version, he do lot many things. He just not do jumping. He also swim. He also dive, skydive. He do lot many things, right? So I hope whenever you compare the 2D version with 3D version, always we have a tendency to like the 3D version more because it looks so lively and also it has a better visualization. It's just not relevant for the games or the fun activities what we do on the web. It is very much relevant to the lab activities also. Whenever you do or run an experiments in 3D environment, you generally get a better results, more relevant results to the real physiological conditions. So in this current presentation, what we'll do is that we'll try to understand what is 3D cell culture. At the same time, we'll also understand why it is important for us to culture cells in 3D environment. And then later, we'll also touch upon that how we can do the 3D cell culture. So there are three critical points which we'll be learning or which we'll be understanding, discussing today. One is the basics of 3D cell culture. What is 3D cell culture? The second one is what is the importance of 3D cell culture? Why we have to culture the cells in 3D? And the third one is how we can culture the cells in 3D. So moving on, let us begin. What is 3D cell culture? I request all of you to be active, be an active listener. Whenever you have any post your questions there. We'll definitely take up your questions at the end and we'll answer them. Right? So let me begin. What is 3D cell culture? So as I mentioned earlier, like Mario, the cells in our body will be in a 3D environment, right? The cells will suspend in a 3D environment where cells will interact with the other cells or the neighboring cells in all the directions. So generally, whenever you grow the cells in a 2D environment, the cells will only interact with the cells which are on the left side or the right side of the cell. But here, when you grow the cells in a 3D environment, cells will not only interact with the neighboring cells on left and right, they also interact with the apical surface cells and also the basolateral surface cells also. Along with that, cells also interact with various extracellular matrix proteins. So in a nutshell, in order to define 3D cell culture, we can say that when we culture the cells in a 3D environment to mimic the relationship between the cells and EC environment, we call it as a 3D culture. So artificially, when we grow the cells in a 3D environment, where if we are mimicking the natural environment, we call it as a 3D cell culture. As simple as that. Okay. So probably you might have heard the 2D culture, right? So 2D culture is more about growing the cells on a flat surface, flask. Probably in the earlier presentations, Ankur or Shubham or Aparna might have shown you how the cells are grown on a flat flask. So here, when you stuff in a 3D environment, we call it as a 3D cell culture. Alright? So when you see the cells in the 2D, as you could see that cells are bit stretched because they are adherent to the flat surface. But when you start growing these cells in a 3D environment, complexity will increase. So as you move from the left side to the right side of the screen, you could see that the complexity is increasing because the cells are grown in a 3D environment with lot many variables or lot many factors. So for example, most of you maybe in the next few slides, you'll also understand a bit more about some of these aspects. But if you also have an experience in cell culture, probably you might have heard about the spheroids. So spheroids are nothing but the cells. It's the cells which are in a spherical shape. So these are nothing but these are aggregates of cells. So when you have the cells, maybe a few cells which are coming together to form a ball shape, we call it as a spheroids. So these are very simple form of a 3D structures. All right. When you further grow them in more complex environment, where you provide some attachment factors, where you provide some growth factors and also hormones, what you would see that you would also see the cells would form a organ shape. So those we call it as a organoids. So probably you might have heard that organoids are being used to test various drugs also. So the key while we are growing the cells in a 3D environment, the structure and physiology will be pretty much similar to the tissue how you see in our real body, which means that the relation or the characteristics what we have in 2D cell culture is very distinct to the characteristics what we have in a real physiological environment. But when you grow these cells in a 3D environment, they would be resembling much better, or they would mimic the physiological conditions in much better way. All right. So please try to understand this way, that as you grow the cells in a 3D environment, the complexity increases. As the complexity increases, the biological relevance will also be improved. So when we say biological relevance, what I mean is that you might have heard that cells are being used to test drugs, right? So in any drug discovery process, the scientists first what they would do is they would test the drug molecules on cells, right? And if they see that the drug molecule is showing a good activity, then what they do is that they will move on, or they test the drugs in animal models. Once even in the animal experimentation, the drugs if it has shown a good efficacy, then they would try to do a clinical trials, which means that they would test in humans. But the problem is, in most of our drug discovery experiments, the failure rate is very, very high. One of the reasons could be that the models what we are using while we are testing the drugs in vitro may not be very relevant, because we are testing the drugs in a flat surface cultures, or we are testing the drugs on a cell cultures, cells which are adhered to the flat surface, which are not really mimicking the real physiological environment. Hence, we may see that there is a good chance of drug failure, right? So our intention from this presentation is we want to show that what is the importance of 3D cell culture and how we can increase the biological relevance while growing the cells in 3D. Right? I hope all of you are clear with the basic definition of 3D cell culture, right? So I'll just quickly summarize. 3D cell culture is nothing but a cells when you artificially grow the cells in a 3D environment, we call it as a 3D cell culture. So when you start increasing the complexity of this 3D environment by adding various attachment factors or by adding some scaffolds, the biological relevance would be significantly improved. So when we have a high biological relevance, then we would be having a high success rate in all our experiments, be it drug discovery or tissue engineering or any other experiments. So the intention of our study is to increase the biological relevance using this 3D cell culture. Right? So far we understood the importance of what is 3D cell culture. Now let us understand why 3D cell culture. Again, here I want to explain this with another analogy here. I hope many of you play games, right? So here I just shown you one example of badminton, where on the left side you see this is a singles game, and this here we have a doubles game on the right side. So when you want to test the expertise, or when we want to test the efficiency or proficiency of this player, the singles player in doubles game, if you directly ask him to play doubles game, we may not really identify his strengths because he is very much used to this singles environment, because the environment what we have in singles game is very different, because here he has a lot of space to cover, he has to go front and back. But when we ask him to play the doubles game, definitely we cannot identify his strength. The same example you can also take it to the cell culture also, or drug testing also. Whenever we are testing some cancer drugs, for example, when we grow the cells in a different environment compared to the physiological environment, obviously the drug efficacy cannot be known perfectly, because we are testing the drugs in an artificial environment which are not mimicking the real physiological environment. Hence, it is very important, if you want to test any drug or anything, we have to grow the cells in the right environment. For that, the cells should be definitely mimicking the physiological environment so that we can understand the real efficacy of the drug, right? So I hope this analogy makes some sense. So what I'll do is that I'll try to play this video so that you will also understand what is 3D culture, and what I mean, what is the difference between 2D and 3D, you will understand from this video. So I will play this video. Can
Venkat, there is no sound coming for this video. I'm not sure whether there is any or you'd like to speak.
So there should be sound, but what I'll do is that I will explain this video. Probably I don't want to waste time. So I'll quickly explain the difference or give a voiceover what the video shows. Okay. So here what we are saying is we want to show that how the cells grow in a 2D environment. Consider this is a Petri plate, all right? So when we have the cells on a flat 2D environment, you could see that the cells are adhering to the flat surface, and then slowly it will be stretched, right? You could see that these are stretched, and the cells can only interact with the cells which are kind of a left and right side of their position, right? At the same time, you could see that when you grow the cells on a flat surface, what happens is the cells will distort because it will flatten. It will not maintain its real physiological structure. As a result, it will form a monolayer, right? You could see, right, that whenever you add a media, consider this is a flat surface, and when you grow the cells here, the cells will be flattened here. And when you add any media, the nutrients, the cell will get nutrients only from one side, which is from the apical side. So there is no interaction with the environment from the bottom side, right? So now let us see that how different it is in growing the cells in a 3D environment. So just trying to show that, literally in 2D, the cell-to-cell interaction is limited. But when you grow the cells in a 3D environment, consider that this is some scaffold here, and the red portion is nothing but the cells. When we zoom in, you will see that in a scaffold, you will find some space, right? When you grow the cells in 3D environment, what happens is the cells are forming an aggregate. So which means that they are forming a 3D shape, right? So when we have